Dear learners, welcome back to my YouTube channel. I hope you are finding my videos helpful. Please do like, share and subscribe with your friends and your brothers and sisters who are preparing for the board exams. So this will be the continuation video for numericals for the topic mirror formula and magnification. So here I have taken the first question, I think which we have not discussed in the previous video. So here you can see the question. Find the focal length of a convex mirror whose radius of curvature is 32 cm. I think we have not discussed this relation before. So let's discuss this relation and let's use it in the numerical, because you may get this type of questions also in the boards. So the relation between radius of curvature and the focal length. So you have to know that. So radius of curvature is twice of focal length. Or we can also write this as, if we cross multiply 2 on the other side, then F is equals to R divided by 2. So whether it is a convex mirror or a concave mirror, so this relation is true for both. The spherical mirror, R stands for radius of curvature and F stands for your focal length. So whenever radius of curvature is given, you can find out the focal length using this relation F is equals to R divided by 2. So in the spherical mirror, you have seen whether it is a concave mirror or a convex mirror. This is the center of the mirror is called as the pole. Then here we have the focus, and double of that will be the center of curvature. So this distance is your focal length F, and this distance from P to C, this is your R. So that's why R will be twice of F, double of focal length. So that's what we have written here, and from there we get F is equals to R by 2. So I hope you have understood this relation. Now let's use this relation to find or to solve this question. You have to find the focal length of a convex mirror. So the mirror that is given is your convex mirror. So first write down the mirror. So it will be easy for the sign convention. So the convex mirror is given, and what is given? The radius of curvature is 32 cm. That means the given term is your radius of curvature, which is 32 cm here. And what do you have to find? You have to find focal length. So our objective is to find the focal length of this convex mirror whose radius of curvature is given as 32 cm. So this is very simple numerical question that we are starting with. So we know the relation between F and R is F is equals to R by 2. So here you simply put the value. R is how much? 32 cm divided by 2. So you will cancel this to 1 to 16 times, or F will be equal to plus 16 cm. Now why we have written plus here is simply because we know this is a convex mirror. If it was a concave mirror, then we should have written minus 16. Alright. So the sign convention is important. So for convex mirror, focal length will be positive. So that's why we have written plus 16 cm. If the same question was given for a concave mirror, then focal length you can take it as minus 16 cm. So in the other numerical, I'll show you how we can use this relation to find other quantities as well. Alright, so this is the second question. So let's read the question first. So a convex mirror is used for rear view mirror in an automobile, has a radius of curvature of 3.00 meter. If a bus is located at 5.00 meter from the mirror, find the position, nature and size of the image. So automobile means vehicles. So I hope you have seen the drivers using the mirror in the vehicle to see the vehicles or any object behind their car or vehicles. So this is called as the rear view mirror. So an automobile uses rear view mirror, and the mirror they have used is a convex mirror. So here first you will write the name of the mirror that we are using here. So we have a convex mirror. So let's obtain the given terms first from this question. So let's see what are the given terms. So a convex mirror is used for rear view in an automobile, has radius of curvature. So radius of curvature is given and the value is 3.00 meter. So you can simply write 3 meter itself. Doesn't matter. So the radius of curvature given is 3 meter. And it says if a bus is located at 5 centimeter from the mirror. So we have a bus which is located at 5 meter from the mirror. So what is this distance 5 meter? What do we keep from the mirror? So we always keep an object in front of the mirror. So here this bus which is located at a distance of 5 meter from the mirror is nothing but our object distance. So object distance u is given. So u is how much? 5 meter here. Now what are the things that we have to find? Find the position. Position means image distance, nature and size of the image. So we have to find 3 things. So we have to find the position, what will be the image distance, then we have to find the nature of the image that is formed, and we also need to find the size of the image here. Size of the image we can find it through magnification also. So we can find it using M here. So these are the 3 things that we have to find out. Now the first thing that we can see, we need to find out the value of V. Now in order to find the value of V, we can use mirror formula. Now for using mirror formula, we need 2 things. In order to find V, we must have the value for U and F. But before we use the formula, we need the sign convention. So let's use the sign convention here. U is the object distance, so object distance will be always negative. Now we have U, we need to find out V. Now we need one more thing, that is focal length. But here instead of focal length, what is given? Radius of curvature. So if radius of curvature is given, we can easily find out the focal length using the relation F is equals to R divided by 2. After that, we can use the mirror formula and find out V. So do not panic if the terms are not given or the values are not given. So think clearly the relations. So first here, we will use the formula F is equals to R divided by 2. So the value of R given here is 3. So 3 meter divided by 2. So if we divide 3 by 2, we will get here 1.5. So this 1.5, the unit is meter here. So focal length, we are getting 1.5 meter. Now you have to use the sign convention here. So what kind of mirror we have? We have a convex mirror, and the sign convention for focal length will be positive. So plus 1.5 meter is the focal length. So after we have found out the focal length, we already have the object distance. Now using mirror formula, we can calculate the image distance. So let's use the mirror formula. So using mirror formula, so mirror formula is 1 by F is equals to 1 by V plus 1 by U. So again, since we are finding V, let's keep V separately, single, and let's bring U to the left hand side. So this becomes 1 by F, you bring plus to the left hand side, it becomes minus. So minus 1 by U is equals to 1 by V. Do not put the value here, it may confuse you. So first, please arrange the equation and then it becomes simple, put the value and do the calculation. So let's put the value now. So 1 divided by focal length is our 1.5 meter. Then we have this minus sign. Then U is our minus 5 meter. So this is minus 5 meter is equals to 1 divided by V. So we have just replaced the value or put the value of F and U here. So after this, let's arrange this equation further. So this becomes 1.5. This minus into minus becomes plus. So 1 divided by 5 equals to 1 divided by V. So if you have problem solving with the decimal, you can write this as 10 divided by 15 plus 1 by 5 equals to 1 by V. So what we have done here, 1.5 can be written as 15 divided by 10. So that 10 goes to the numerator, so we can write 10 divided by 15 here. So now you can find the LCM of 5 and 15, which will be 15 itself. So here we have 10. So 15, 1 time is 15. So this 10 will be multiplied with 1. Then we have plus, here we have 1. 5, 15 will be 3 times. So we'll multiply it with 3. So you have to work on this section if you have problem to find the LCM and do the calculation. So here 10 into 1 gives us 10 plus we have 1 into 3, this gives us 3 divided by 15 is equals to 1 by V, or we get 13 divided by 15 is equals to 1 by V, or we will get V is equals to, if you cross multiply, this becomes 15 divided by 13 and the unit here will be meter. So let's divide this, don't leave it like this. So divide 15 by 13. So when you divide 15 by 13, you will get the image distance as 1.15 meter. So you are getting plus 1.15 meter. So this is the image distance. So we have found out the position of the image here. Now, before we write the nature, let's see the size of the image. Now, in order to calculate the size of the image, we can use two formulas. If we have the value of m and height of the object, then we can easily calculate the height of the image. But here, height of the object is not given. So, let's use the formula m is equals to minus v by u. So, from there we get the magnification, and magnification will tell us the size of the image, whether it is magnified or whether it is diminished. So now in order to find out the size of the image, we are using m equals to minus v divided by u. So m is equals to minus v, we have obtained it as 1.15 meter, and object distance we have as minus 5 meter. So we are simply putting the value of v and u here. So here you can simply cancel meter and meter. So this becomes minus into minus becomes plus. So this becomes 1.15 divided by 5. If you are having problem with the decimal, then you can simplify this further. You can write down m is equals to 115 divided by 100 into 5. You have 2 digits after the decimal, so it will be divided by 100. So let's simplify further. So you can write this as m is equals to 115 divided by, or else you can what you can do here is you can divide like this: 5 1 5 2 times 5 3. So if you divide 5 and 115, so it becomes 23, and here you will get 1. So you will get 23 divided by 100. Now 23 divided by 100, you can simply write it as m is equals to 0.23. So here you are getting magnification as 0.23, and you can see that the value of magnification is positive here. You are getting a positive number, but the value is less than 1. So from the obtained values, we can see the nature of the image now. So you have calculated the image distance, which is the position. Size of the image you have already calculated, 0.23. Now what we can do is simply write the nature. Since the image distance is positive, so positive means image is formed behind the mirror. So what kind of image is formed behind the mirror? The image which is virtual, and virtual images are always erect images. So the first nature that you can write here is the image formed is virtual and it is erect image. Now the second thing, if you look at the magnification, from here also you can see that the image will be virtual, because for virtual images magnification is positive. For real images magnification is negative. So from here also we can say that the image is virtual. From here also we can say, since the image distance is positive, means behind the mirror, so it is virtual, and virtual images are always erect. Now if you look at the size magnification, it is less than 1. So if the magnification is less than 1, then we know that the image is diminished. If magnification is equals to 1, then we say that image and object are of the same size, and if magnification is greater than 1, then we say that the image is enlarged. So for that you have to see the video that I have made for mirror formula and magnification. So there I have explained everything, so you can check that video. So since the magnification is 0.23, it is less than 1, we can say that the image is diminished. So this is how you will determine the nature. So for that you need to have some concepts. So this is question number 2. So let's discuss the third question. So the question says, a concave mirror produces 3 times magnified or enlarged real image of an object placed at 10 cm in front of it. So what do we have to calculate? Where is the image located? So this is short numerical which may carry 1 marks, or it may come in the choose the correct option type questions. So here you have to obtain the given terms through the sentence. So here we have 2 values. So one you can see, first of all, let's say the mirror. So you write the name of the mirror. What kind of mirror we are using? We are using a concave mirror. Alright. Now one value we can clearly see here is 10 centimeter. So what is this 10 centimeter? Object placed. That means we have an object which is placed at a distance of 10 centimeter in front of the mirror. So this 10 centimeter is nothing but our object distance. So here u is equals to 10 centimeter. So the other value that is given is magnification. So you have to, sometimes the value is given in numerical form, sometimes it is given in words. So here it is given in words. So a concave mirror produces 3 times magnified image. That means magnification will be how much? It will be 3 times, means it will be 3. And you have to also see that the image formed is real image. So for magnification, the sign convention you have to see if the image is real or virtual. So if the image is real, the sign convention will be negative. If it is virtual, then it will be positive. So here the image formed is real, so magnification will be negative. Object distance is always negative. And what do we have to find out here is image located, means we have to find the image distance. Now here, in order to find the image distance, we cannot use the mirror formula. So it is not always suitable to use mirror formula. So you have to really read the question carefully, see the given data and think which formula is suitable. So here we can see 3 things: magnification, image distance, object distance. So do we have the relation between these 3? Yes, we do have the relation or definition for magnification. So let's use that. So we know m is nothing but it is minus v by u. So all the 3 terms are here. So v we have to find out, m is given, u is given. So you can simply use this formula and calculate v. So let's put the value. Before we put the value, let's arrange the equation. This can be written as v equals to minus m times u, or v is equals to minus m is how much? Minus 3, and u is how much? Minus 10. And here we have centimeter, so let's write this as 10 centimeter. Now v is equals to minus into minus becomes plus, plus into again minus becomes minus. So v will be negative, 3 into 10 will be 30, and unit will be centimeter. So this is how you will calculate image distance without using the mirror formula. So this is short numerical which may carry 1 marks. Okay, so let's discuss now question number 4. So the question is very lengthy, but do not get panicked, okay, looking at the question. It's very simple. So you do read the question carefully, understand, and then answer. Alright, so the question says, we wish to obtain an erect image of an object using a concave mirror of focal length 15 centimeter. what should be the range of the distance of the object from the mirror, what is the nature of the image, is the image larger or smaller than the object, and draw a ray diagram to show the image formation in this case. So you may get panicked looking at the length of the question, but it's very simple. So let's start how to solve this question. So what kind of mirror do we have first of all? So we have a concave mirror. So we have a concave mirror. Now let's see what is given. So we have focal length, which is 15 centimeter. So the given term here is focal length, and this is 15 centimeter. Now read the question carefully. Here you don't need any calculation. If you know the concept, you can answer directly. So what you have to find out is what should be the range of distance of the object. That means where should an object be kept from the mirror, so that we can get what kind of image? Erect image using what kind of mirror? Concave mirror. So I have already discussed this in the image formation by a concave mirror. If you haven't checked that video, please do go and check that video, the last case. Concave mirror forms real, virtual and erect image only when the object is kept between the pole and the focus. So here they are asking you the range, from what distance up to which distance the object will be placed, so that we can get an erect image. So the answer is very clear. If you keep the object between the pole and the focus, then the image will be virtual and erect. So focal length here will be negative since we have a concave mirror. Here we don't need any calculation. If you have understood that last case for concave mirror, then you can simply write range of the object should be from 0 up to 15 centimeter. That means you have a concave mirror, you have this pole, and you have this focus. So the focal length is 15 centimeter here. So if you keep an object in between these 2 points, that is pole and focus, wherever you keep it, whether you keep it here, whether you keep it here, at pole the distance is 0, up to this the distance is 15 centimeter. So from 0 up to 15 centimeter, in between, wherever you keep the object, image formed will be always virtual and erect. So you are asked the range from which distance to which distance the object should be placed. So the range has to be from 0, that is from pole, up to focus. From 0 to 15 centimeter, in between, anywhere you can keep the object. So that is the first question. Now the second question is, what is the nature of the image? So as the image is formed behind the mirror, I have discussed everything in that video, so you can go and check that video. So if the image is formed behind the mirror in this case, then the image formed will be enlarged or magnified, and it will be virtual and erect. So the second answer, nature of the image will be, it will be virtual image, and virtual image is always erect, and also it will be enlarged or magnified. Okay, then the next question is the image larger or smaller than the object? So you can write here, image is larger than the object, because here the image is magnified. So the height of the image will be always greater than the height of the object. So it will be larger. And the last thing that is asked is to draw the ray diagram to show the image formation in this case. So for this, I would like to suggest you to go and watch the video image formation by a concave mirror, the last case where image formed is virtual and erect. So don't get nervous, don't get panicked, and don't leave the question just thinking that the question is very lengthy. Sometimes you just have to know the concepts to answer the question. So this is very simple. So I hope I have been able to do almost all types of numericals here. If you need any help in any type of other numerical related to mirror formula and magnification, you can just comment in the video. So that's all for now. Thank you everyone, and please do like, share and subscribe my video, and share it with your friends and your brothers and sisters. Thank you.